Hello everyone, myself Ashutosh Sadaria. In the previous video, we covered about expansion buses, its types, organizations, standards and also an ISA bus. In this video, we will cover rest of the bus designs. So let's see the list of different designs of buses which we use in different computers. The first is ISA bus that we covered in part 1 of this video. Rest of the buses we will cover in this video. The next is MCA bus. Full form of MCA bus is micro-channel architecture. The next is EISA bus. Full form of EISA bus is Extended Industry Standard Architecture. The next is VLB, VESA Local Bus. The next is PCI bus, Peripheral Component Interconnect bus. The next is AGP, Accelerated Graphics port. The next is IEEE 1394 FireWire port. And the last is USB, Universal Serial Bus. So ISA bus we covered in the first video. The second bus is MCA bus. Full form of MCA bus is Micro-Channel Architecture bus. Using this, IBM attempted to replace ISA bus with something bigger and better. MCA is 32-bit wide and offers several significant improvements over ISA bus. It had far superior throughput to the ISA bus. The MCA bus supported bus mastering adapters for greater efficiency, including proper bus arbitration. MCA automatically configured adapter card, so there was no need for mess with jumpers. The two main reasons for MCA would be failure in the marketplace. First, MCA is not backward compatible to ISA. Backward compatibility means when new technology arrives and it works with older technology, that you can say that new technology is backward compatible to old technology. That means ISA card will not work at all in MCA systems. Second, IBM decided to make MCA bus proprietary. So, other manufacturer cannot use it in their computers without purchasing license from IBM. The next is EISA bus. Full form of EISA bus is Extended Industry Standard Architecture. Group of 9 companies led by Compaq developed an open EISA standard bus to counter proprietary MCA bus developed by IBM. Compaq avoided the two key mistakes that IBM made. First, they made it compatible with ISA bus. As you can see from the diagram that they extended ISA bus by using 2 pins on each side instead of 1 each side. Second, they opened the design to all manufacturers instead of keeping it proprietary by forming the non-profit EISA committee to manage the design of the standard. EISA was similar to MCA both in terms of technology and market acceptance. It had significant technical advantages over ISA. Some of the key features of EISA bus are as follows. The first is ISA compatibility. ISA cards will work in EISA bus as it is backward compatible. Second is 32-bit bus width. Like MCA bus, the bus is expanded to 32 bits. The third is bus mastering. EISA bus supports the bus mastering adapters for greater efficiency. And next is plug and play. EISA bus automatically configures adapter cards similar to plug and play standards of modern systems. You just need to attach cards to the EISA slots and you can work on that device. The next bus we are going to discuss is VLB. Full form of VLB is VESA Local Bus. VESA stands for Video Electronic Standards Association, a standards group that was formed to address the video related issues in personal computers. This is the first local bus to gain popularity. VESA Local Bus, also called VL Bus or VLB for short, was introduced in 1992. Major reason for the development of VLB was to improve video performance in PCs. It is the extension of ISA bus and ISA card can be used on VLB. So we can say that VLB slots are backward compatible to ISA. There were also several key problems with VLB. First is the design was strongly based on 80486 processors. So adapting it to newer Pentium processors caused a host of compatibility and other problems. The bus itself was tricky electrically. For example, if you connect more than one cards in the bus, then the bus will not work properly. Sometimes you can connect only one card on the bus. The bus did not support bus mastering properly since there was no good arbitration scheme and did not support plug and play also. The next and most popular bus is PCI. The full form of PCI is Peripheral Component Interconnect. It is also a local bus. PCI was developed by Intel in 1993. It is geared specifically to 5th and 6th generation system. Although the latest generation 486 motherboards use PCI as well. PCI allows developers to design cards that will work in any PCI compatible machine. It overcomes the limitations of ISA, EISA, MCA and VLB buses. And it offers performance needed for today's fast systems. There are many similarities between PCI and older VLB specifications. Both are local bus with 32-bit data path and burst mode. Also, the original PCI design operates at 33 MHz, roughly at the same speed as VLB. Now we see the functioning of PCI bus in various areas. The PCI bus performance. The PCI bus provides superior performance to VLB, and PCI bus is the highest performance than general I/O bus currently used in PCs. This is due to several factors. First is burst mode. PCI bus can transfer information in a burst mode. The second is bus mastering. The PCI bus supports full bus mastering, which leads to improved performance. Third is high performance bandwidth options. PCI bus has specification of version 2 calls for expandability to 64 bits and 66 MHz speed. If implemented, this would quadruple the bandwidth over current designs. And the next is PCI bus expansion slots. PCI bus offers more expansion slots than VLB implementations. Most PCI systems support 3 or 4 PCI slots. Also, the PCI bus offers great variety of expansion cards compared to VLB. The most commonly found cards are video cards, high-speed networking cards, hard disk drive also on the PCI bus, but are normally connected directly to the motherboard on a PCI system. The next is PCI internal interrupts. The PCI bus uses its own internal interrupt system for dealing with respect from the cards on the buses. And the last is plug and play. PCI systems were the first to popularize the use of plug and play. PCI bus is a part of plug and play standard developed by Intel with cooperation from Microsoft and other companies. The PCI chipset circuitry handles identification of cards and works with the operating system and BIOS to automatically set the resources allocated for the compatible peripheral cards. The next is AGP. Full form of AGP is Accelerated Graphics Port. In the early days of PCR, major market for the technology was high performance display adapter. Today, the PCI market includes various devices that pose the problem for display card designers. Having more cards on single bus slowed the performance. Just when the increased popularity of 24-bit graphics and 3D rendering called for greater demands on the display system. So, solution was the single slot tuned for the display adapter. Once again, Intel came to the front and developed the Accelerated Graphics Port. AGP removes all the display data traffic from PCI and gives the traffic to its own 525 Mbps pipe into the system's chip and from there to processor. It also provides a direct path to system memory for handling graphics. This procedure refers to Direct Memory Execute or DIME. AGP connectors are found on Pentium 2 based computers and later computers or on similar CPUs from non-Intel based vendors. The next bus is IEEE 1394. It is also known as Apple trademark of FireWire. It is a high performance and serial interface bus. While connecting external peripherals, IEEE 1394 has a possible replacement of SCSI. This high-speed serial interface allows up to 62 devices in a chain at a data transfer rate of 50 Mbps. This new interface offers several advantages. A hot swap capability, the ability to add and remove components while the machine is running, small and inexpensive connectors, and simple cable design. Right now, few devices supports 1394, but it is seen as a viable method for connecting multimedia devices like camcorder and other consumer electronic devices which require high-speed data transfer to PC. And the last bus is USB. The full form of USB is Universal Serial Bus. The newest addition to the general PC bus collection, the USB connects external peripherals such as mouse, printers, modems, keyboards, joysticks, scanners, and digital cameras to the computer. USB port is thin slot and most new motherboards offer two located near the keyboard port. They can also be provided through an expansion card. USB supports isochronous, also known as time dependent, and asynchronous, also known as intermittent data transfers. Isochronous connections transfer data at a guaranteed fixed rate of delivery. This is required for more demanding multimedia applications and devices. Asynchronous data can be transferred whenever there is no isochronous traffic on the bus. USB supports different data transfer rate depending upon the amount of bus bandwidth a peripheral device is required. The first is 1.5 megabits per second, asynchronous transfer rate for devices such as mouse, keyboard that do not require a large amount of bandwidth. And the second is 12 Mbps isochronous transfer rate for high bandwidth devices such as modems, speakers, scanners and monitors. The guaranteed data delivery rate provided by isochronous data transfer is required to support the demand of multimedia applications and devices. So that's it for today's video. These are some important questions from the video. The first is explain MCA bus. Second is explain backward compatibility. Third is explain key features of EISA bus. Fourth is explain problem of VLB bus. Fifth is explain functioning of PCI bus. The next is explain AGP, and the last question is explain USB. So that's it for this video. So in two parts, this video and previous, we covered topic of expansion buses. Hope you understood all about expansion buses. Thank you.